Hey guys, welcome to Math 1, where we will be doing the notes from Chapter 2, Section 6 today, so 2.6. And today we are going to talk about taking our skills of writing linear equations and using those skills to write and understand linear equations for real situations. All right, so you can see up here our objective is to represent a real situation with a linear equation. And now that we know all the parts of the linear equation, or at least like the slope and the y-intercept, and how to write a linear equation in different situations, this will not be too difficult probably. I have done 3 examples here, and each of the 3 examples will point out some different aspect of doing this. So, we are starting with just writing equations for a linear situation, and I think this is the key right here. The key to writing an equation for a linear situation is understanding that slope is equal to rate. All right? It's the rate that something is happening. It's how fast something is growing, whether that's a person, a tree, or a bank account. Or it is the rate that something is dropping, like the stock market, or a body of water. I would like to point out that in addition to rate, right, we like to use what is called the unit rate. And the unit rate is when you divide the rate, right? You have y minus y, the slope, right? Y minus y over x minus x. When you go ahead and divide that and make it a single number, you get a unit rate, which means you get the bottom unit to be 1. For instance, maybe your rate is miles per hour. So it's miles in 1 hour. It's called a unit rate because it is in 1 unit, 1 hour. How many miles you're traveling in 1 hour. Or maybe how many dollars you earn per week. If you make $500 in 10 weeks, that's not a unit rate. But when you divide it, 500 divided by 10, and you get $50 per week, now it's a unit rate because it's per 1 unit, 1 week. All right, the other thing is the y-intercept. The y-intercept is commonly known as the starting amount. You know, I like to joke that the letter B is used for the y-intercept, right? The letter M is used for slope. And why do we use the letter B for the y-intercept? Sometimes I think is because it's the beginning amount. I don't think that's truly why, but it's why I say it is. All right, so slope is equal to rate, and the y-intercept is equal to the starting amount. So anytime you calculate the slope in a problem, or anytime you see a rate in a problem, those things are interchangeable, as are the starting amount and the y-intercept. All right, so that gets us ready for our first example, a really easy example, but I'm going to point out a few things that will help you on your homework. Johnny plants a tree that is 3 feet tall when he plants it, right? He went to Oakland Nursery, he bought a little sapling, 3 feet tall, he planted it, and it grows 1.5 feet per year. Write a linear equation for the height of the tree, h, in terms of y. All right, so this equation is for the height of the tree, which means my equation is going to be h equals something. The height of the tree equals what? In terms of y, where y is the number of years it has been growing. All right. So one thing that they might do for you, or you might need to do at some point, is make a table for the situation. You could make a table for this situation by making an XY table, except it's not XY, it is Y and h, and just using logic to make this table. After 0 years of growing, when you first planted the tree, it was 3 feet tall. And then it grows 1.5 feet per year. So after 1 year, it would be 4.5 feet, right? So this is the height when planted. And here we have the height after 1 year. And I guess I could do one more point. After 2 years, how tall would the tree be? Well, another 1.5 feet. So that would be 6 feet tall, right? All right, so when you make a table now, essentially you have made ordered pairs that would be on this line. And you could use those ordered pairs to write the equation for the line. All right? Could use those points to write the equation. And we're going to do that, but what we want to do is transition probably to not having to do that when we have a story problem. So once we have a table, we can calculate the slope and the y-intercept and write the equation, right? Let's start by calculating the slope. So my slope is going to be, I'm just going to take a couple of ordered pairs from the table. I'll just take the first 2 ordered pairs, and I'll go 4.5 minus 3 and 1 minus 0, and I'll get 1.5 over 1, which is a slope of 1.5. All right? Now look. See how the 1.5? See how the slope was the rate. All right, look back up here. 1.5 feet per year turned out to be the same as the slope, 1.5, 1.5. And that's one of the things we hopefully have learned, is that the slope and the rate are the same thing in a problem. And I could also use this table to find the y-intercept if I wanted to. We'll do that in purple. So to find the y-intercept, I might take one of the ordered pairs, like 6, 2, and I might say 6 equals 1.5 times 2 plus b. That would be 6 equals 3 plus b. And if I subtract 3 from both sides, I get that the y-intercept is 3. Now remember, what does the y-intercept mean? This is the y-intercept, of course, but that is the starting height. And look, even though I calculated the y-intercept to be 3, back in the problem, I already knew it was 3. They told me it was 3 feet tall when I started. I just wanted to point out that if you calculated it, it would be the same thing. All right, so now that you know your slope, which is 1.5, and you know your y-intercept, which is 3, you can write the equation for this in slope-intercept form, right? So it would be y equals 1.5x plus 3. Except we don't want to use those variables because they told us that the y was actually h, the height of the tree. That's what I'm actually calculating. And this x is actually a y, which is the years it's been growing. So make sure that when you write your equation, you use the variables that they tell you to use and not always use x and y. I have now written an equation that represents the height of the tree. And I could have written that equation without ever making a table or calculating the slope or the y-intercept if I just know that, let's go red, I guess, the rate that it's growing, this is the slope. And the starting height is the y-intercept. And if you can just pick those things out of a problem, boom, you can write the equation immediately. All right? All right, let's look at another example real quick. Two more examples. You want to make sure you recognize if the slope is positive or negative. So I have another example here where it kind of points that out. An example, the professor borrowed $600 from Mr. Howell. He agreed to pay him back. Does anybody know who the professor and Mr. Howell are? I'm just telling you, if you know, you can tell me in class. The professor borrowed $600 from Mr. Howell. He agreed to pay him back $40 per week until the debt was paid off. Write an equation for L, the amount the professor still owes on the loan, in terms of W. And W is the number of weeks that he has been paying him back. So what's going on in this problem? If I were to graph this problem, this would be L, which is the amount of the loan, and this would be W, the number of weeks he's been paying him back. And this loan starts at like $600, and the amount of the loan is going down, right? Because he keeps paying him back. So you should recognize from that graph that the slope is negative, right? Here's what we know from the situation. We know, oops, I want to do that in green. We know that the starting amount, what is the starting amount of the loan? Well, the starting amount is $600, right? We got that right here. Borrowed $600. And what is the rate? What is the rate that he is paying him back? You know, often rate will have this, this key word right here, per. That per tells you it's the rate. And he's paying him back $40 per week. So the rate is 40, but since, I think we should write this down, since we, are measuring the amount the professor still owes. Let's see, since we're measuring the amount the professor still owes, and it is going down, this is what tells us the slope is negative. So M actually equals negative 40, which is the amount he owes the professor goes down 40 per week, right? And since we now know that the starting amount is 600 and the slope is negative 40, we could write the equation, right? That is L equals, right? L is the amount of the loan, is equal to, now instead of writing mx plus b, when I write these equations, I like to start with the starting amount actually, 600. And what is happening to the starting amount? It's going down $40 per week. So I have identified the starting amount, I have identified the rate, and I can go right to the equation. There is really nothing to calculate there, right? If you like writing it better in slope-intercept form, like this, you can. I just kind of think it makes more sense to say the amount of the loan started at $600 and it's minus $40 per week. But either way is certainly correct. All right, last example. Let me whip this one out. Giving a starting amount and another random point. All right, so in this story problem, you're not going to be given the rate. You are going to be given the starting amount. So, of course, that's the y-intercept. And you're going to be given a random point. What do we do with that to find the rate? Well, there are two ways to get the rate when you are not given it. I could use y equals mx plus b, or I could use the slope formula, which is the same as the rate formula, because slope and rate are the same thing. And I could use that to find the rate. I'll show you both ways real quick. All right, so I got this plumber who charges a fee of $50 for a house call. Just to show up, he charges $50. And then he charges an additional hourly rate, but I don't know what the rate is. One day the plumber earned a total of $600 for an 8-hour job. All right, that's like knowing a random ordered pair, right? If I were to graph this, my graph would look something like cost, hours, and it would look something like that. Where an ordered pair on this graph might be 8 hours, $600, something like that. And what they've done is they've given me the ordered pair right here. This is like the y value, which in our case is C for cost. And this is like the x value, which in our case is H for hours. So instead of xy, this is actually HC, but it's still an ordered pair, right? All right, so I know the starting amount. The starting amount is $50. And I can find the rate because I can find the rate by using y equals mx plus b, because I actually know a point also. I know the point, 8 hours, $600. So I can use those three numbers. Oops, almost put that in the wrong spot. I can use those three numbers and I can solve for m. All right, this is my x, this is my y, this is my b. The starting amount, your y-intercept. And I would say 600 equals m times 8 plus 50. And I would subtract 50 from both sides. And I would divide by 8. And I would get $68, oops, 68.75. That is my rate. This guy charges $68.75 an hour. And now that I know the rate and I know the starting amount, I could write the equation for the situation. Or, I promised you the other way, I could use the slope formula. But remember, slope is rate. Maybe you'll like this one better. I take my ordered pair. Let's see. I know that I know this is an ordered pair also, the starting amount. After 0 hours, he makes $50. And then, of course, I have my other ordered pair, 8,600. So I could do y minus y over x minus x. That would give me 550 divided by 8. Same thing I had over here, by the way, which would give me 68.75. And again, I have found the slope, or the rate, right? And so I could now write the equation for this. Do I have to write an equation? It does say write an equation. I could write the equation, and the equation would be the cost equals, what is it, 600? $50. $50. Sorry about that. Here, I'll erase that quickly. I'm trying to get you out of here. The cost equals $50 plus 68.75 per hour. I found the slope, the rate, I found the beginning amount, and I wrote the equation. All right, good luck on the homework.